So welcome to another video of Dave's shaky lab demonstrations on what we're going to be doing here. So what we're going to be doing in this is, again, this is the circuit you would be building in lab, this bandpass filter here that you would have designed. And we're going to go ahead and build this, and I'm going to show you precisely how I'm able to build circuits of any resistor value here. So there are these little things here. Let me pull out some of these devices here. There are these devices here that, let me turn it so it can be read here, that are called resistor substitutors. And so I can actually set whatever resistor value I want. Like it's set at 60 kilo ohms right now. Now, I mean, when I say I can set it to whatever I want, it's within reason. So let me go ahead and show you what I mean here. But if this would not keep falling down on me. Maybe it's because these things, there we go. Let's try this here. Okay. So it's set at 60 right now. And I'm just plugging it in here. So it's actually at 60.1, but I can mess with this here. So I put it at 50, and then I can say, okay, well, I'm going to increase this to 59. Okay, so that's 59 kilohertz, but then I can adjust this to, okay, 59.5, 0.8, and 60. And then you see it's set at 60, but I have it at 59.9 kilo ohms there. So I can set my resistor value to whatever I need. Now I'm not going to be that precise with my design and setting them. I have been kind of precise with your designs. So I have an 820 ohm resistor. So I'm going to go ahead and set that up here. And the reason I don't use these in the lab normally is that, well, you don't ever put these in a, oops, that's the wrong thing. You never, I mean, these aren't going to obviously be put in circuits in real life. You have to use real component values. But because of the circumstances we're in, I'm going ahead and using these so that I don't have to have a big, massive amount of resistors and capacitors at home. So I can still collect your measurement results. So you can see I've set this for 820 ohms. The other resistor, I've got another one of these, was at 47 kilo ohms. And so I'll go ahead and just, I mean, it's just a dial here, so I'll set these to 47. So 47 kilo ohms. And then I do go ahead and still measure these resistances for you. So I don't just set them, so I do measure them. And so when I say these are the measured values, that's what I'm actually doing. So like if this was one I'd be using for you, this would be 47.1 kilo ohms is what I'd email to you as far as the measured value. And then as far as the 820 ohm one, if I measure that one, 0.821. Okay, and then I need a 1 nanofarad capacitor and 2.2 nanofarad. And you can see I've got a substitutor here for the capacitor as well. And we've got microfarad, nanofarad. So I mean I can do, you know, a couple microfarad if we need to. But that's also, I can't make them too small. I can't really go into the picofarad range. So I might be able to do a 0.1 nanofarad, but as you can see, a 0.1 nanofarad would be something like this, which it's probably not going to be that reliable. So we want to really be in the, if possible, be in the 1 nanofarad or larger for your capacitors. And then also you could go up to the microfarad if you needed to. Um, and then the other capacitor we said needs to be 2.2. So I will go ahead and put that at 2.2 nanofarads. And then this multimeter has the ability, I'm changing the mode here. And I'm just hitting the mode, here I'll go back here and show you. I'm hitting the mode button several times. And then I get this where, notice that the units here are NF for nanofarads. And so I can actually go ahead and measure, and again, this is what I do when I measure for your labs. I can measure what this is. And so this is actually a 2.2, well, it's kind of bouncing back and forth. Let's see if it sells. 2.279 nanofarad capacitor. Maybe, yeah, I'll say 2.279 nanofarad capacitor. So that's what I'd email you. And then this one here is a 1.08 nanofarad capacitor. And so that is what I would email you regarding that. Okay, so that's how I'm doing these circuits for you guys. So let me go ahead and clean up my space a little bit here. And so I am going to go ahead and show you here how I'm going to build this circuit here. It's going to be a little bit odd here. So I've got my low pass filter that I'm putting in first. And so the low pass filter has that resistor with a capacitor then. And so my resistor here, let me get the correct resistor here. This is the one that I want here. This is actually the one that I want is the 820 ohm. I don't like the colors of my wires, but I'll survive with it. So this is my 820 ohm resistor. And let me get some more wires out of the way here. So I'm not going to use those probes. Okay, so here's my 820. So I'm going to put the, let's just say, I'll put the blue end here. So that's going to be where my input is coming into. And then I'll put one of the black ones here. So that's where the capacitor that goes to ground is going to connect to, which is my 1 nanofarad capacitor. So I have my 1 nanofarad capacitor, and then I'll go ahead and just use this rail here for ground. So that's my ground. Then I have the 2.2 nanofarad capacitor that's connected into the same point here. And then it's got to be connected up to the other resistor. So that's my other capacitor here. And then I've got my resistor here, my 47k ohm resistor, that's then also connected there and connected into ground. So clearly the circuit here, I mean, you can, this is one reason we also don't do it. I mean, this is a bestial looking circuit here. And you can imagine what it's going to be like when we get into using op amps with these later on. But as far as for our purposes right now, it really makes it handy so that we can still have you do some computations, we can do measurements, and it's not that everyone's getting the same numbers, which is what I really like. All right, so now we need to go ahead and connect up the network analyzer. So this is my output here that I've got with some wires. And so this ground needs to go, and I've already calibrated and everything. So the ground needs to go there. And then the output is across the, well, wait, this just came out here. This should be right here. The output is across the 47k ohm resistor. So I put the output there with the 47k ohm resistor. Now I need to put my inputs, and I have my inputs, and I've got just one wire for my input because I got both the signal and then the oscilloscope. So I've got both of their grounds connected to the single wire. And then I've got here, I gotta fix it up here. I've got both of the signal in and the measurement probe to the input, which would be on the input of the 820 ohm resistor. So now I'm going to come over here to my network analyzer. Awesome. Now it doesn't look like it's in the right state here, but once we've got it all configured once and everything, and you don't change the probes, you don't have to constantly reconfigure it, but I don't have to constantly reset it up either. I'm going to go over to here. Notice that there's this save recall button, which is actually very useful. If I'm going to click on that save and recall, and then there are save state and recall state. I've already saved the state, but if I recall state, what you can do is you can recall all of the settings that you've already made once, so you don't have to constantly do it. So I'm going to recall state 1, and then we can see, wait, it's already set up for T over R and phase, and the scaling's all correct here. Everything's all correct. Now let's just do my sweep setup just to make sure we can see, or not my sweep setup, my stopping frequency. And yeah, we're going up to 10 megahertz, so that's good. That's what I thought. So that's what we did in our, well, apparently I'm turning a bunch of audio. Let me turn that back down. And I'm going to do here a single sweep. And so I'm going to let this start to run, and you're going to see the measurements start to form there. It goes slow at first on the left, and you can see it's starting down low, because remember 0 dB, which is what we should be getting, is all the way up here. And it should start speeding up. And we get that very nice bandpass filter. Now we get this slightly odd behavior at high frequency, and that just has to do with some issues with the low pass filter. When you get to high frequencies, the particular design of our low pass filter, there's some issues that happen that are beyond the scope of this course. So we don't really need to worry about that weird bounce up behavior at the end there in that high frequency range. But we can see we get this nice little pass band here. And now we want to be able to measure, and so that we can determine if our Q factor, our band pass, or our pass band, or bandwidth, I should say, omega C1, omega C2, or FC1, I should say, and FC2, and then our center frequency, if they're all correct according to our simulations and computations. So I'm going to do again here a marker search, but instead of doing a target value, I'm going to do multi-target value, because what multi-target value is going to do is it's going to look for any time we hit this target value. So I'm going to hit -3 decibels. And it says, well, you hit that twice. So I hit it once at 1.56 kilohertz, so that's the low frequency one, and then another at the 170 kilohertz. Well, that doesn't seem that great. And it's not. I mean, I was supposed to get 200. My simulation clearly said 200. So something clearly is going on when we put the real components going on here together. It's not because the simulation has an error or that we did an error in a computation. It's just there's got to be something that we're ignoring or that we're not accounting for. Now, one thing you can kind of play with is saying, okay, well, I want that frequency to be higher. Okay, so what could I do? Well, I could make, if I want that to be higher, I make some of my values smaller. So I'm going to go ahead and reduce the size of my capacitor to 1.2 nanofarads. And we're going to run this again here and see what happens. Now, I'm not going to necessarily be able to do this for you, but we could run multiple experiments if you want to do that as well. Because maybe reducing that one to 1.2 nanofarads is not the correct way to go. I think I may have adjusted the wrong frequency one here. So let's do marker search, target, marker search, multi-target. multi-target minus 3 dB. Yeah, actually what I did is I changed the wrong capacitor value there, so let's change that. And then let's change my other capacitor value instead and do a single now. See what happens. Well, we can see what's going on here. I changed the other capacitor to make it small, and now I changed the other capacitor back to the other original setting. And so I made that other capacitor, instead of 1 nanofarad, I made it 500 picofarads, or 0.5 nanofarads. And now if I do a marker search again here, multi-target. Okay, well now I can see I have 1.5 kilohertz, but now I've gone up to 320 kilohertz. And so I could continue to play with it. You might say, well, wait a minute, you know, that doesn't seem like a very logical way to do things. And the reality is sometimes this is the way that design has to be done, because your simulation doesn't necessarily account for every single little thing. And how do you know if it's going to work? Well, you do is what's called prototyping. You actually, like what we're doing here, you build the circuit and see what the response is. Now, if the response is not what you're getting, it doesn't mean that somehow there's a computation that's wrong somewhere. It means that we're probably missing something as far as, you know, we made an assumption to make calculations easier, to make the simulation easier. And that assumption that we made is making it so that we're getting frequencies that don't fit into our design parameters. And so you have to tweak the values. And you see now I'm getting closer. I have a 1.5 kilohertz and a 238 kilohertz one. So I'm tweaking the values here. So you can see here, by tweaking values, you can actually get the filter designs to be closer to what you want it to be. Now, that's an option if you get your measurements into me soon enough and I can get the measurements back to you. You have the option to tweak, which would be kind of a nice little thing to add into your reports. But if you don't get the designs back to me quick enough, I won't be able to do that for you. All right, so that is kind of the measurement. So we're doing the exact same measurements as we did last week. We're now just looking at a bandpass filter. And in fact, the measurements we're going to be doing subsequently are going to be the same. When we get to active filters, there's going to be one additional thing that's going to mess and make this even a more bunch of a jumbled wired mess here to actually do this with active filters.